from what I just did up above, right? Didn't I find out that this value here is going to be 0? So this is just going to be f of 0. What is f of 0? I just substituted this in, just like we did yesterday when we did our composite functions. We found the value of the inside function and then substituted in our outside function. What do we get when we do f of 0? Look at your graph. Get -3. That's pretty interesting. How about this? If I do f of the inverse of, let's say, -1.782, what's that going to give me? Anybody know? Zero or -1.782. Which one? Richie, why are you saying that? Why are you saying -1.782? Yeah, think about what happens if we do the function after we've done the inverse function. Isn't that the whole idea of inverses? It just reverses what you just did. Okay? It's, again, like squaring a number and then square rooting it. What are you going to end up with? Same thing. Okay? And so the same thing's going to happen here. If we substitute in, we're going to get them flipped around, and then you're going to do the value of the function of that. It's going to flip it right back. Just think about those tables. We made a table that flipped them. We changed it. This is going to change from B to A, and then this is just going to switch it right back to A to B. Okay? So again, no matter what, we'll start out with AB. The inverse flips it, and then we're going to flip it back. And it doesn't matter the order, right? Remember, if we had x squared and we square rooted it, or we had the square root of x and then squared them, didn't we end up right back where we started, no matter what? Okay. So that's what the value of our inverses are. I don't have to do any fancy calculations. You show me this, I know what the answer is going to be, -3. Okay. Let's take a look at an application problem here. Okay. It says that a car requires a certain distance to come to a complete stop, where this distance is based upon r, which is the rate at which it's traveling in miles per hour. It says write a function to express the speed r at which the car is traveling as a function of the distance d required for it to come to a complete stop. So it says let's take this and flip this around. In other words, d equals 6.97r minus 90.39. And we're going to do like we did up above. We're going to solve, we solved this for y when we switched them around. We're going to solve this one for r. So the first thing, obviously, what we're going to do is go ahead and add the 90.39 to both sides. Then we're going to go ahead and divide everything by 6.97. That'll leave us with, and again, I'm using my symmetric property to pull this around. This will be r equals 1 over 6.97 times d, and then plus, I don't have my calculator, whatever this is. And there you have it.
How'd you get rid of the D?
I didn't get rid of the D. Okay, so I divided these two and got 1 times R, and I'd use my symmetric property and just pulled it over. I have the D that I divided by 6.97, so that's where this is. This is the D right here, times 1 over 6.97, whatever that is, plus this. Okay. Let's take a quick look here at these guys, and it says if f of 3 is -1, what's going to be the value of the inverse of f if I substitute in -1? What's that going to give us? We've got one person that's seeing it. Remember, this is our input 3. This is our output -1. If this is indeed an inverse function, if I substitute in -1 here, what should I get out? 3. Okay, when I do the inverses, I'll end up back with where I started. This is going to equal 3. So again, what should this next one be? 17, right? Do I need to calculate anything here? No. I don't even know what this is. I know when I put in, let me write this way. Okay. When I put in 17 in the inverse function, I get something out. Don't know what it is. But I know if I put whatever that is into my g function, if these two things are indeed the same, I better get 17 back out of this. So yes, this is simply equal to 17. And the order doesn't matter. I could do this one. What's that going to give me? 12. Okay. Again, like squaring and square rooting it. That's how inverses work. All right. So hopefully you're able to manage through each one of these. By definition, knowing that I'm just switching my A's and B's, I should be able to recognize that they are reflection across the line y equals x when I graph them. Understand the horizontal line test tells me that the inverse will pass the vertical line test. And I can check that we have inverses by substituting in and getting x when I solve those. If I get anything else, they are not inverses. Okay? And I can write an inverse by just switching the x's and y's and do the algebra to solve for y. And finally, that whole idea of inverse substituted back into the original function will give me whatever I started out with. All right. I think we're done for the day.